Solar is booming, but silver demand from solar can flatten or even fall at the exact same time. That sounds impossible until you realize solar has two engines running in opposite directions. One engine is scale. The world keeps installing more panels. The other engine is thrift. The industry keeps learning how to use less silver per panel, less silver per cell, less silver per watt. So the real story is not solar up equals silver up. The real story is a race. Gigawatts versus milligrams. Scale versus thrift. And whichever one wins determines whether solar stays the big industrial bid under silver or whether that bid quietly stops growing, even while solar farms keep spreading across the planet. If you want a calm, mechanism-based analysis like this, subscribe. This channel does not do slogans. We do systems. And share this with a friend who keeps repeating viral silver math, because this episode will save them from the easiest mistake in commodities: confusing a booming industry with booming demand for one specific input. Now let me show you the paradox in a way you can feel. Picture a solar farm at sunset. Rows and rows of panels stretching like a dark ocean. From a distance, it looks simple. Sun hits panel, panel makes power. Multiply it by 1 billion rooftops and deserts, and you get the energy transition. But inside each panel is a tiny set of lines, thinner than you expect, doing the most important job in the entire device. They collect the electricity and move it. And for decades, the metal used for those lines has been silver. That is why investors learned a simple story. Solar grows, silver demand grows. That story was true for a long time. Then solar became too big, and silver became too expensive. And the industry did what every high-volume manufacturing industry does when a volatile input threatens margins. It started a war on silver, not a public war, a quiet war. A war fought in factories, in paste formulations, in metallization patterns, in new cell architectures, in equipment upgrades, in yield improvements, in tiny reductions, repeated 1 billion times. And if you do not understand that war, you will keep making the same mistake. You will keep assuming the biggest installation boom automatically translates into the biggest silver demand boom. It does not anymore, not in a straight line. So we are going to build a clean map. First, we will explain how silver is actually used in solar in plain language. Then we will explain why the world is installing so much solar that even tiny silver loadings still matter. Then we will explain how fast the industry is cutting silver and why the tech transition can sometimes increase silver per cell even while thrifting continues. Then we will show you the real future threat to solar silver demand, which is copper. And finally, we will give you the only equation that matters, so you can stop arguing with vibes and start reasoning with structure. Here is the first truth. Solar does not use silver because solar companies love precious metals. Solar uses silver because silver is a great conductor and it has been reliable in manufacturing processes that must run at enormous scale with low defect rates. Inside the cell, you have to collect current efficiently. You do that with metallization, the thin conductive pattern on the surface that gathers electrons and routes them. For years, silver paste has been the workhorse material for that job. The key word there is paste. Solar does not pour silver into a panel like a bar into a vault. Solar uses a processed, specialized form applied in tiny amounts because the job is to create conductive pathways, not to store metal. That is why the unit that matters is not ounces per panel. It is milligrams per watt or milligrams per cell. That is how factories think. That is how they cost it. That is how they optimize it. Now, if you only remember one idea from this episode, remember this. Solar silver demand is not a story about one big decision. It is a story about 1 million small optimizations. And the reason that matters is because solar has become the kind of industry where saving a tiny fraction per unit becomes a massive amount of money across global volume. When an industry reaches that scale, it will attack any cost input that behaves like a tax. Silver has been that tax. So now we turn to the scale engine. Yes, solar is booming. The numbers are no longer small enough to ignore. The world is adding solar capacity at a pace that would have sounded like fantasy not long ago. Every year, the base gets larger, and the additions stay large. And the pipeline keeps coming because solar has become one of the fastest ways to add new power capacity. This is important because it means you cannot dismiss solar as irrelevant to silver. Even thrifted silver loads multiplied by massive gigawatts can still be huge in aggregate. That is why the paradox is real, not a trick. Scale is massive, but thrift is aggressive. So you must watch both. Now we turn to the thrift engine. If you run a solar factory, silver is not a romantic metal. It is a line item that can swing, and swings are poison for manufacturing planning. When silver prices rise, paste becomes more expensive. When paste becomes more expensive, margins compress. When margins compress, thrifting becomes survival. So the industry has been reducing silver intensity for years. How do they do it? They print finer lines. They reduce the width of the fingers. They optimize the pattern so less metal does the same electrical job. They improve contact quality so they can use less material without losing performance. They refine paste formulations. They push equipment to higher precision. They improve yield so less silver is wasted. None of that sounds dramatic. It is not. It is manufacturing reality. It is the kind of reality that changes demand curves quietly. Now comes the part that confuses people. Solar cell technology is changing, and different cell types use different amounts of silver. So you can have a world where silver per cell is being reduced by thrifting, while at the same time the industry shifts towards cell types that, at least for a period, can be more silver intensive. That sounds contradictory, but is exactly how transitions behave. For a long time, one technology dominated. Then the industry began migrating toward new architectures, often for efficiency and performance reasons. New architectures can require different metallization patterns, different contacts, different processes, and that can affect silver use. So you cannot just ask, is silver per watt falling? You also have to ask, what is the mix of technologies being deployed, and how does that mix alter the baseline? This is why you see periods where demand seems stubborn even when thrifting is happening. Scale pushes up, thrift pushes down. Tech mix shifts sideways. Now let us talk about the elephant that can change the whole story over time. Copper. If there is one word the solar industry loves more than efficiency, it is cheaper conductor. Copper is cheaper than silver. Copper is abundant compared to silver. Copper is the obvious replacement target. So why has silver survived for so long? Because replacing it is not as simple as swapping one metal for another on a spreadsheet. You have to make it work in a high volume process. You have to make it reliable. You have to keep yield high. You have to prevent corrosion and failures. You have to pass qualification tests. You have to convince manufacturers and buyers that the new approach will not create warranty disasters years later. In other words, you have to win against the factory. Factories are conservative for a reason. A small defect rate at huge scale becomes an ocean of failures. That is why copper substitution has been slow. But slow is not the same as impossible. And this is what makes the solar-silver paradox so important right now. Because once copper metallization becomes reliable at mass scale, the long-run ceiling on solar-silver intensity drops dramatically. If copper becomes a standard metallization pathway in major cell architectures, solar can keep growing while silver per watt falls faster than ever. That is the heart of the bear case for solar-driven silver demand. Now we stay honest, just because copper is possible does not mean copper is already everywhere. The gap between a lab result and a factory standard is huge. A lab can set a record. A factory has to make millions of cells every day. So the right framing is not copper will replace silver tomorrow. The right framing is copper is a credible long-term threat to silver intensity. And the industry has every incentive to push in that direction as fast as reliability allows. Now we bring it back to the pressure cooker. Solar manufacturing is intensely competitive. Prices compress, technology shifts, factories fight for survival. That environment accelerates thrifting because cost cutting is not optional. It is how you stay alive. So when you combine scale, competition, and an expensive input, you get relentless optimization, which brings us to the only equation you need to keep this entire story grounded. Solar silver demand equals how much solar gets installed, multiplied by how much silver is used per unit of solar. Installations times intensity, gigawatts times milligrams per watt. That is it. This is why solar can boom and silver demand can flatten. If installations rise by a certain percentage, but intensity falls by the same percentage, total silver demand stays flat. If intensity falls faster than installations rise, silver demand falls. If installations rise faster than intensity falls, silver demand rises. The entire debate collapses into that math. So why do people still get confused? Because installations are visible. You see the farms, you see the headlines, you see the growth. Intensity is hidden. It lives inside manufacturing process improvements, pace formulations, and engineering decisions that do not trend on social media. The market loves visible stories. The market often misses invisible stories until the effects show up in demand data or in pricing behavior. Now, we are going to make this concrete with scenario thinking because this is where you stop being manipulated by narratives. Imagine a world where solar keeps installing at a historic pace and silver thrifting continues, but only gradually. In that world, total solar silver demand can remain very large and might keep rising because scale overwhelms thrift. Now imagine a world where solar keeps installing at a historic pace and thrifting accelerates. Because silver stays expensive, competition stays brutal, and copper pathways mature. In that world, total solar silver demand could flatten because thrift catches up to scale. Now imagine a world where installations slowed for a period, maybe because of policy changes, grid constraints, or financing conditions. While thrifting continues and substitution accelerates, in that world, solar silver demand can fall even while solar remains a massive industry. None of these worlds require solar to fail. They require only that solar becomes more efficient in its use of silver. That is why this is not a solar doom story. It is a solar evolution story. Now, if you are thinking, fine, but how do I know which world we are in? Here is the payoff. You do not guess by emotion. You watch 3 dials. Dial 1 is the pace of installations, not the hype. the actual pace. Dial 2 is the pace of intensity reduction. How fast silver per watt is declining in real manufacturing. Dial 3 is substitution maturity, whether copper metallization is moving from experiments into reliable production. If installations are strong and intensity reduction is slow, solar remains a strong silver demand engine. If installations are strong and intensity reduction is fast, solar becomes a less reliable silver tailwind and more of a cap demand story. If substitution matures, the long-run intensity ceiling drops and the relationship between solar growth and silver demand changes permanently. Now, we close this first half with a reality check that will keep you sane. Even if solar thrifts silver aggressively, solar can still be a huge contributor to industrial demand because the scale is massive. But the direction of growth is what changes. Solar can remain large, yet stop being the driver of incremental growth that investors assume, and incremental growth is what moves prices at the margin. So the next step is to do the thing almost nobody does when they talk about silver and solar. We are going to run the scenario math in a way that makes it obvious what has to be true for solar to remain the dominant growth engine for silver, and what has to be true for solar to become a story of volume without rising silver pull. And once you see that, you will stop falling for the simplest trick in commodity narratives. The trick of assuming that the biggest industry automatically means the biggest incremental demand for a specific metal. So let us run the logic the way factories run it. Imagine solar keeps growing year after year, adding more capacity than the world used to add in a decade. That is the scaly engine. Now imagine, at the same time, manufacturers keep shaving silver out of every cell because silver is expensive, volatile, and unforgiving. That is the thrift engine. If those two engines move at the same pace, total silver demand from solar can look flat even while solar is exploding. If thrift moves faster than scale, solar silver demand can fall even while solar keeps growing. If scale moves faster than thrift, solar remains a rising demand engine and stays a central pillar in the silver story. That is why people who only watch solar installations keep getting surprised. They are watching only one engine. Now, let us make this more intuitive without turning it into a spreadsheet. Think of a factory manager staring at a margin line that keeps getting squeezed. Module prices fall, competition intensifies, financing is tight, and every input cost becomes a battle. In that world, silver paste is not a nice, it is a cost target. So the factory does what factories do. It pushes the metallization team to shrink the silver lines. It upgrades printing precision, it tweaks paste chemistry, it squeezes waste out of the process. It improves contact quality so less material does the job. It does not do this once. It does it every quarter because survival demands it. This is why the solar story is not just about demand. It is about industrial behavior under pressure. Now we add the layer that makes the story even more interesting and more dangerous to oversimplify: technology mix. Solar is not one cell type forever. Solar evolves. For a long stretch, one mainstream architecture dominated global volume. Then the industry started migrating toward newer architectures that offered better efficiency and better performance, especially under real-world conditions. That migration can change silver intensity in two directions at the same time. On one hand, every manufacturer is trying to thrift silver, so intensity per watt tends to fall with time. On the other hand, certain high-efficiency architectures can be more metallization intensive in specific ways, especially during early scaling phases when processes are not fully optimized. So you can have a period where the world installs more solar, the world shifts to a different cell architecture, and the industry is still thrifting, and the net result is messy. Silver demand can remain stubborn or even rise temporarily, not because thrifting stopped, but because the technology mix created a higher baseline before thrift caught up again. This is why you will see two people look at the same year and argue opposite conclusions. One points to the scale and says silver demand must be rising. The other points to thrift and says silver demand must be falling. The truth is that both forces can be present at once, and the outcome depends on which one has the stronger grip during that specific phase of the cycle. Now we come to copper, because copper is the long shadow over this entire story. If silver is the tax, copper is the escape plan. Copper is cheaper. Copper is abundant. Copper is what engineers reach for when the mandate is simple: deliver the same function at a lower cost per unit. So why is copper not already everywhere in solar method? Because the question is not, can copper conduct? Copper conducts. The question is, can copper survive inside a solar cell and inside a module for decades through heat cycles, humidity, mechanical stress, field conditions, and warranty expectations? A solar manufacturer does not sell a phone that can be replaced in 2 years. A solar manufacturer sells a long-lived asset expected to perform for decades. Reliability is the product. So when you replace silver pathways with copper pathways, you inherit a new family of problems to solve: corrosion risk, adhesion, contact resistance stability, process control, uniformity at scale. The possibility that tiny defects become massive field failures years later. This is why the copper transition is slow, and also why you should take it seriously, because when it works, it changes the ceiling. The moment copper metallization becomes reliably manufacturable at mass scale in major architectures, the industry's ability to cut silver intensity accelerates, not just by a small optimization, by a structural shift. And that is why solar is no longer a simple silver bull argument. It is a contested territory. Now, to keep this episode honest, we have to say the quiet part out loud. Even if copper is technically possible, adoption will not be instant. Factories do not swap processes overnight. Factories adopt what works, what qualifies, what passes the brutal test of yield and warranty confidence. So the right question is not, will copper replace silver tomorrow? The right question is copper becoming credible enough, reliable enough, cheap enough, and scalable enough that manufacturers begin treating it as a real pathway, not a laboratory curiosity? And that brings us to the most practical part of the entire episode. How do you know which side is winning, scale, or thrift without guessing? You watch the dials, and you watch them the same way a factory watches them, not the way a comment section does. Dial 1 is the pace of solar installations. If the world keeps adding capacity at a blistering pace, the scale engine is strong. Dial 2 is silver intensity, measured the way manufacturers measure it, silver per watt, silver per cell, silver and metal. The faster that number declines, the stronger the thrift engine. Dial 3 is substitution maturity, not a press release. Evidence that copper-based metallization is moving from demonstration to reliable production, and that the equipment and process ecosystem is stabilizing. When these three dials move together, the story becomes obvious. If installations are rising strongly and intensity declines slowly, total demand rises. If installations are rising strongly and intensity declines fast, total demand can flatten. If installations are rising modestly and intensity declines fast, total demand can fall. Now, here is where most people make a second mistake, even after they learn the equation. They assume the market will respond smoothly. It will not. Markets respond to surprises, and surprises happen when the narrative everyone believes collides with the data nobody was watching. If investors assume solar guarantees rising silver demand, and then intensity drops faster than expected, the market can be disappointed. If investors assume thrifting will cap demand, and then installations surge while intensity remains stubborn because technology mix shifts, the market can be surprised the other way. So you do not want a single story. You want a framework that survives different outcomes. Here's the framework. Solar is a demand engine, but it is also an optimization engine. Solar can grow while silver intensity falls. The net demand depends on the race. Now, let us talk about what the real-world confirmation looks like, because this is where you stop being theoretical. If solar is still pulling silver demand higher in a meaningful way, you will tend to see evidence in industrial supply chain behavior. You will see persistent tightness in specialized silver powders and pastes. You will hear manufacturers talking about paste costs as a major pressure point. You may see a stronger industrial bid in the forms of silver that matter to manufacturing inputs. Not only the forms that matter to retail stacks, you will see a sense that the industry is paying for certainty, not only shopping for a bargain. If, on the other hand, solar silver demand is flattening or being capped, the evidence will show up differently. You will see adoption of copper pathways moving beyond experiments. You will hear manufacturers talking more confidently about silver reduction targets being met in production. Not just on paper, you will see a steady march toward lower silver loadings that is not interrupted by rising silver intensity from tech mix. Now, we also need to address a third layer, because solar does not evolve in a vacuum. Solar evolves under macro conditions. When financing conditions tighten, solar installations can slow in certain markets. When grid constraints intensify, projects can be delayed even when demand exists. When policy support shifts, installations can accelerate or decelerate quickly. This is why you cannot treat installations as destiny. You treat them as a dial that responds to policy, grid, and capital. So you watch both the macro pulse and the manufacturing pulse. Now let us steelman the bullish case, because it deserves respect. The bullish case says even with thrifting, solar is now so large that the aggregate demand remains huge. The world is installing at such scale that shaving silver per unit may not reduce total demand if installations keep growing. It also says that during technology transitions, some architectures can temporarily require more, and that copper substitution may be slower than the market expects because reliability is hard. In that world, solar remains a powerful bid for silver, and any further acceleration in installations can matter a lot. Now let US steelman the bearish case. The bearish case says the industry's incentive to thrift is relentless, and the easiest large cost target is silver paste. It says the competition and margin pressure in manufacturing will keep forcing silver intensity down. It says copper pathways will keep maturing, and once they reach reliable production, the intensity ceiling drops and solar becomes less dependent on silver for incremental growth. In that world, solar remains huge, but solar stops being the growth driver people assume. And silver demand growth must come from other sources or from other industrial expansions. Notice something important. Both cases can include solar growth. The difference is silver intensity. That is the paradox. Now let me give you the clean verdict framework that makes this usable, not just interesting. If you want to know whether solar will keep driving silver demand higher, you do not ask whether solar is growing. Solar is growing. You ask whether the industry is still paying a meaningful silver tax per watt, or whether it is escaping the tax faster than solar is scaling, and the market will tell you the answer through the behavior of intensity metrics, substitution announcements that translate into real production, and the physical supply chain stress signals that show up when industrial demand is bidding for deliverable inputs. Now, if you made it this far, you are exactly the kind of viewer this channel is for. Subscribe, because this series is building a complete map of silver demand drivers, not just repeating the same old narratives. And share this episode with one friend who keeps saying solar guarantees a silver boom, because the truth is better than the slogan and far more useful. Now we close with the simplest, most honest statement we can make about solar and silver. Solar is no longer a single lever for silver. Solar is a tug of war. Scale pulls demand up. Thrift pulls demand down. Technology mix can tilt the rope temporarily. Copper is the long-term threat to silver intensity. And the only way to understand which force is winning is to watch the dials, not the headlines. Solar can keep booming. Silver demand from solar can still flatten. And if you understand that, you will stop being shocked by the market's behavior, because you will finally be watching the right variable, not panels intensity. Because in the end, solar does not decide silver's future by how many panels it installs. It decides silver's future by how much silver it needs to install each one.